Hello. Thank you, Edico, for this introduction and warm us up. I hope you guys can enjoy today's sessions. And my name is Shuquan Huan. I'm from 99 Cloud. So at the beginning, I have give you a brief introduction about 99 Cloud. 99 Cloud was founded in 2012. We are the earliest evangelists of OpenStack in China, and we start our business in OpenStack training. So right now, we are the largest OpenStack training organization in China. Also, we start our contribution in OpenStack since 2012. We are contributing OpenStack regarding in the technical and community building. So we are the top 3 contributor in China and top 10 contributor globally. We use open source technology to enable our customer to resolve their real-world problems. We are members of OpenStack, CNCF, Linux, and many other open source community. Right now we have the largest market share of OpenStack in energy, financial banking, and other many vertical industry in China. Today, I will, first of all, let's look at the history of computing. As we all know, cloud dominates the IT discussion in last 2 decades, right? Particularly with the Amazon, he released his EC2 services in 2006, and OpenStack come out in 2010. That is a huge event for the cloud computing. As we all know, cloud computing is centralized all the cloud computing services in the data center so that we can take advantage of the shared data center and use the economy of the scale to reduce our costs and improve the efficiency of our daily work. There are different types of cloud: public cloud, private cloud, hybrid cloud, and we can use the software as a service, platform as a service, and infrastructure as a service for the cloud. So what happened for the next 10 years for the computing history? I think edge computing is not the end of the cloud computing. Actually, edge computing is the natural involvement of the cloud computing. It's because cloud computing has to extend its scope to meet different requirements and fit the different use cases. For example, let's see, for the external factors like the smart cities and the AR, VR use cases, it required the cloud computing to have more capability to meet those requirements, especially in the industry 4.0. I will talk about it later on. And on the other hand, we can see right now the architecture of cloud computing, it has little optimized for the use cases, especially in the small footprint platforms and for the unreliable network, high bandwidth network and low latency, such kind of use cases. So edge computing can bring our major 4 values to help to resolve all of these problems. For edge computing, we can have highly responsive cloud services. We can have real-time edge analysis in the IoT. We can also have more security in the edge side. Another thing is we can mask the disruption of the cloud services. So what does the edge computing do with the industry 4.0? Just as my understanding, I think the edge computing can act as a nerve ending of the manufacturing. What's nerve ending? Actually, for the nerve ending, it brings the intelligence to the manufacturing IoT devices. Without the edge computing for the manufacturing, all the IoT devices for the manufacturer, it may be just acting some simple actions. But with the edge computing, we can bring the real-time analysis and bring some intelligence pushing to the edge so that we can have the intelligence in the IoT devices. So let's take a look at the textile industry. To start the textile industry problems statement, I would like to introduce you the manufacturing process of the textile. I don't know if you guys know how we come with the fabric. Anyone know the process? Okay, it's great. Actually, the textile manufacturing process is a conversion of the fabric to is the fiber to yarn and yarn to the fabric. Okay, I looked the face with the confused, right? First of all, we will use the spinning process to bring the fiber into the yarn, and we will weighing the yarn. It will turn to the fabric, and we will dyeing and printing some patterns, some color or some pictures in the fabric, and will come out the finishing as a product. But we cannot ship the product to the customer. It is because we may have some defects in the fabric. So we have a very important step is the inspection. After the inspection, we can deliver the fabric to our customer. So for the traditional inspection process, it depends on the human. The fabric defect detection is very necessary, as I just said, because it's a quality control in the textile industry. And the quality inspection of the fabric surface is highly important before we shipping this product to the customer. Let's see what's the defect of a fabric. It's just like the picture shows. It's a flaw on the surface resulting from the manufacturing processes. So the human have to standing beside the machine and watching the fabric and find the fabric. It's a very high cost because the human labor, and it's low efficiency and not consistent and not stable. So for the traditional, we have this architecture to resolve this problem with some kind of systems, automatic system. There are 3 steps to help us to detect the fabric defect. First one is image capture. Second one is defect detection. The last one is the post-processing. The image capture procedure is majorly responsible for the image capture with some high-resolution camera. We camera a lot of the pictures of the fabric, and then we can run some algorithm, machine learning algorithm based on these pictures, a lot of pictures, and we will find if there are any defects in this fabric. We localize this defect and segment those defect regions so that the worker can help to reduce this, remove this defect later on. So the last procedure is the post-processing procedure. What's that? Actually, we will do the defect type classification and defect grade assessment and defect remove mode. In this traditional architecture, as you see, we put all the application in the central cloud. So when we're doing the image capture process, it captures a lot of high resolution pictures. We have to sending a lot of these images back to the cloud, so it's high bandwidth in the network. And in the post procedure, if we are going to control the machine to remove some defect, it will have high latency when the cloud sending command to the machine. So edge computing can help us resolve these kind of problems. We will set up another edge cloud environment besides the machine. It can be located in the workshop. One workshop have an edge cloud talk to several machines, and we collect the data from the machine and do the feature extra the feature from the image. And for the edge cloud, it's just sending the features back to the central cloud. And the central cloud, it can collect all the features from different workshops and run another further algorithm to help us to update the model, and then it can push in the intelligence to the edge side to update the model in the edge side. So as this process running again and again, we can have more high precision prediction for the defect. Also, if we are going to do some automatically defect removal process, we can use the edge cloud to directly control the machine in the workshop. So as a result, we're working with our partner. We have proved the velocity of this systems is about 5 or 6 times to the human's velocity. That's a pretty good start result. But we can also see even we have this kind of edge optimized architecture, but we can only resolve some kind of fabric. For example, some color fabric or some specific pattern fabric. We have to optimize the application in the central cloud to improve we can recognize different types of fabric. And also, we have to optimize the network between the central cloud and the edge cloud. For more information about this shell, I welcome you guys to join the session tomorrow. I can explain in detail to you guys. Thank you.